It's up to you, Donald. You need to get more distilled water for your Keurig. Ah, you put distilled water in yours? Oops. So, let's learn about this. So, this information is coming from Next Spaceflight. Next Spaceflight is operated by a buddy of mine named Mike Baylor. He does a really good job here. It's basically, you want to know what launches are coming up? Check the Next Spaceflight. So, this is an orbital mission launching the O3B mPower 1 and 2. There's 2 satellites stacked on top of each other. The first stage booster day is 1067 on its 8th flight, landing on a shortfall of gravitas. 44-day turnaround, 168th Falcon recovery attempt. The mPower satellites are improved second-generation satellites for the SES-owned O3B network. 2 payloads stack on top of each other, going to a medium Earth orbit, launching out of Slick 40 at Cape Canaveral Space Force Station. This will be the 180th orbital launch attempt in total in 2022. SpaceX's 201st mission, 58th mission of this year. That's absurd. And Falcon 9, it'll be Falcon 9's 192nd mission, 57th mission for Falcon 9 of 2022. Wait. Interesting. Anyway. SpaceX launched earlier today. Snickers, yeah, they launched the SWOT mission, which is the Surface Water Oceanographic Topography satellite. SWOT was launched out of Vandenberg on booster, 1071, I believe. That was its 5th flight, and did an RTLS back at Landing Zone 4, the former Slick 4W pad at Vandenberg. Yeah, I guess it doesn't count Falcon Heavy. Heavy, you swap, mate. All right, Tessa. Let's see what we got, dude. I got a nice hot cup of coffee with the walkers. Let's see what we got. Let's see if this is better than the Tim Tam Slam. That's tasty. I needed 2 more for coffee, Hired. Wow. Dude, that has no business making that taste that good. Allie, don't get me wrong. Tim Tam Slams are amazing. I tried it the other day for the first time. Damn. It's frigging delicious. So yeah, SpaceX was supposed to launch a Starlink mission after this. The Starlink mission was supposed to be like a couple minutes after, but they moved that mission to tomorrow. If we go over to Next Spaceflight, it's tomorrow at 4:30. I should be around to cover that, but that's all. I'm just going to do the coverage and GTA tomorrow. Guys, I'm going to put Monday back on the schedule for streaming, and for the rest of the year, I want to do Monday through Friday streaming. Saturday will just be for GTA Racing at night, and Minecraft is moved to Mondays. It's the holidays, stuff's getting a little crazy. I need the weekends, man. Like that's the honest truth. Yeah, this is just Duncan Original, Sawyer. So, for the time being, guys, I'm going to go on Monday through Friday. 11 Eastern Concrete is when it kicks off. Yep. 10 to 11 Eastern. I need another one of these. So, that's Yeah, Minecraft is moved to Monday. GTA racing is still on. Anytime there's a rocket launch on the weekend, I'll be here. Yeah, caveman, it mostly works. Yep, yep. Yeah, Tesla, yeah, you gotta... It's like the Tim Tam. You can't leave the Tim Tam in there for too long. It'll just melt. Damn, that's good. Dude, that has no business being that tasty. I could literally eat that whole box. And I'm not going to, or else Ono's gonna get mad at me. There you go, hypersonic. I need the weekends to straight up reasonable. Bill, I like, okay, so it's the holidays, but also, guys, I'm putting Mondays back on the schedule because, dudes, I need 2 days to maintain the damn house. And if Brimo's with me, we can get all the work done faster. Honestly, homeownership is sweet. I love it. I love owning a house. I love having my own garage. I love everything. You got to take care of everything. You got to take care of everything. Yep. Got hobnobs from Myers. Nice, Liquidator. Nice, nice. Hobnobs are good, man. Yeah, exactly, man. So, yeah, guys, it's maintaining the house. It's just making sure everything is good around the house. You know, fixing things. You know, stuff gets broken. You know, the floors get crappy, rugs shed. Like, dude, it's ridiculous. Like, you know, like, I'll be honest with you, and I'm okay to admit this. Like, it doesn't bother me. Dude, I have no idea what I'm doing. There's nothing wrong with that, you know? Like, I've never owned a house before. My parents made it look so freaking easy. They made it look easy. You know, it's like, they made it look easy. It's not easy. It requires constant upkeep, just like any other system. You know, I'm learning that. This is the first time I've owned a house, you know? Do any of us? Yeah, exactly. Exactly, MacV. You know, when you grow up, you think your parents, oh, wow, my parents really have it together. No. They've been just doing it for longer. All right? I didn't get the instruction book. I think I threw it away, Mab. Stroopwafels and coffee are amazing. Exactly, Access. Yeah, you have to pitch the slopes and stuff. That's why people have lawns. People have lawns to pull the water away from the house, you know? Just in case anybody was wondering, like, why people are so obsessive about the lawn and everything. Yeah, it's so it can pull the moisture away from the house. Exactly, Wisp. If you're not doing maintenance on the house every week, you're falling behind. Dude, yeah. And dude, we have a lot of land. I'm on an acre. Like, okay, I know. If you live out in the farmland, that's nothing. If you live out in the sticks, it's nothing. Acre is a lot for me. I grew up on a quarter of an acre. Like, less than that, actually. Maybe like an eighth of an acre. Like, houses left and right. Like, so this is like a big change for me. I gotta figure out everything that I gotta, you know, take care of. Like, the instruction book was a digital code, and the website it was hosted on no longer exists. Yeah, pretty much. Yeah, you pave around the house, it's dude, you live in a pond. Exactly, dude. Try Tim Tam Slammer. Oh, Cronky, I did it. Dude, trust me, we have plenty of people from Oz watching the stream. They told me to, yeah, you bite both ends. You bite top left, bottom right, and you put it in the coffee, and you pull, right? You suck through it, and it pulls it full of coffee. Dude, it's so good. It's so good, man. It's delicious. Dude, amazing. Oh, I loved it. It was so delicious. In fact, that's what prompted this whole Walker's Biscuit thing. Because Tessa, one of my mods in chat, was like, okay, you like that, try this. And this is also good. Coffee goes good with so many freaking things. If you think soy has become unsafe to return with people on the ISS, would Dragon be considered as an emergency vehicle where they rush a new Soyuz? I'd say get rid of the MS-22 Soyuz. If it comes down, it comes down. If it doesn't, it doesn't. And then just the next Soyuz up there, just launch that and have the crew come down on that one. Yeah. Involuntary DLC, proprietary upkeep. Yep. Or property upkeep. Yep. Not proprietary. But yeah. It will change your life. Dude, Cronky, I had it and I'm like, holy crap. This is delicious. It's freaking delicious, man. I need to do this. I need to do this again. Okay. Oh, that sucks, STX. Yeah, no, we didn't find anything like that. You suck, you jackass. Yeah, you're probably right, but this launch isn't going to.
9, 8,
Launch auto sequence has started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic.
Yeah, I heard, right?
Stage separation confirmed. Dragon, separation confirmed.
Alright, here we go. O3B mPower mission. I think it's a micrometeorite on them. I think a micrometeorite hit it.
Landing legs have deployed. And Falcon 9 has landed.
But there also was stuff about the ISS being in the sun for a longer period of time. That may have done it too. Who knows? But anyway, Falcon 9 time, baby.
The O3B mPower mission for our customer SES. Today's launch marks SpaceX's 190th overall Falcon 9 launch and our 58th
Got
launch
some
of
golden hour.
2022.
Really nice colors.
My name is Shiva, and I'm a space operations engineer here at SpaceX. I'm joining you today from our headquarters in Hawthorne, California.
colors in the sky.
And on your screen is a live view of our Falcon 9 awaiting its 5:48 p.m. Eastern Time launch from Space Launch Complex 40 at Cape Canaveral
Bears, I
Spaceport
didn't see
Station
it.
in Florida. Today we're flying the first of 5 second-generation O3B mPower launches, which will deliver low-latency connectivity services to mobility, telecom, government, and enterprise customers around the globe, with service scheduled to begin in the third quarter of next year.
Depends, TJ.
The O3B mPower satellites were designed in collaboration with SES and Boeing and will operate from the medium Earth orbit, or MEO, and that's about 8,000 kilometers away from the Earth's
Golden
surface.
worm.
The second generation satellites will be joining SES's O3B mPower initial constellation of 11
worm.
high throughput and low latency satellites, as well as their extensive ground infrastructure. Let's learn a little bit more about SES and their mission.
Use Discord, Jacqueline.
It's the moment we've all been waiting for.
I have.
A new era of connectivity is here. With performance above all at its core, SES's second generation medium Earth orbit
it's good.
system, O3B mPower, offers terabit level scale, the highest, most flexible throughput, low latency, and guaranteed reliability, making it the satellite system of choice when performance matters most.
Yeah, where's my
Whether it's
basketball,
governments
Jim?
looking to enable critical missions, mobile network operators deploying networks including 5G, energy companies digitalizing their operations, or world-class cruise operators offering high-speed broadband access to passengers at sea, O3B mPower ensures
makes
seamless
sense, Jim?
operations and premium user experience wherever they are.
So we started this journey back in 2017 as we were trying to figure out
Yo.
how we could bring all of the really good stuff, all the lessons learned from the original O3b constellation, but scale it ridiculously. And so here we sit on the threshold of launching this brand new constellation. There are three things that really differentiate O3b mPower by virtue of where we're flying the satellites from in medium Earth orbit. And the differentiators are it's carrier grade capability, it's wherever our customers need it, and we're completely flexible in the way that we could deliver that bandwidth. And those three things combined make O3b mPower completely unique.
The first 2 satellites of our initial 11
I'm not sure
will soon
this.
be launching into medium Earth orbit. They will join SES's current O3b system at 8,000 kilometers above the Earth's surface, building on SES's pioneering legacy of empowering businesses, governments, and communities in some of the most difficult to reach places on Earth. With O3b mPower, we're taking that experience even further.
O3b mPower is scaled ridiculously from the original O3b constellation, and that means that in all our verticals, in cruise, in government, in fixed data, we're able to serve not just 10 beams per satellite, but 5,000 beams per satellite. So the number of applications that we can support on O3b mPower has just grown hugely, and all with the ambition of making sure that we're supporting all of our customers' networks and all of their needs.
O3b mPower's secret lies in the unique combination of the most innovative satellites, industry-leading ground infrastructure, and advanced software systems, all developed to form a future-proof network ready to bring an extraordinary level of performance to satellite-enabled communications.
Dish, I think this is going equatorial, so it'd be 27 degrees inclined.
When we were presented with a very complex problem that we knew a traditional design approach, a traditional satellite architecture simply wouldn't solve. We needed to design a network in the sky. It's been a tremendous journey of invention.
We're here in historic Cape Canaveral, and we're just a short time away now from the first launch of O3b mPower. And actually, this is going to be the first of 5 launches that are going to happen over the next year or so, and I could not be more excited. And I hope
I've lost
joining
count,
this
silly.
broadcast, you're going to get to witness an incredible launch, but you're also going to get to share in the O3b mPower journey.
No, Laser. No, this is launching from Florida. This is a sea landing,
We are
Jim?
just over 7 minutes away from liftoff, so we're going to take a closer look at the vehicle that you see on your screen. The 2-stage Falcon 9 vehicle stands 229 feet tall. That's slightly taller than a 21-story building. That bottom 2/3 of the vehicle is
Why
called
is there
the
no
first
strobe
stage,
on the left tower?
and sometimes known as the booster. Its job is to accelerate the vehicle through the Earth's atmosphere and into space, and then it will separate away from the rest of the rocket. Now, today's booster is flying for its 8th time. Previously
you
having
can't do
supported
that.
cargo
That's the
resupply
competition.
missions
You can't
22
do-
and
you can't do
25,
that.
Crewed missions 3 and 4, the Turksat 5B mission, Eutelsat Hotbird 13G, and 1 Starlink mission.
Yeah,
Now,
it's
above the
blocked by a
first stage,
threat.
we have our second stage. It has a single Merlin vacuum or MVAC engine, and
Short
that
follow
ignites
gravitas
shortly
landing,
after
Sleepy.
the stages separate. Second stage is what will ultimately carry the O3b mPower satellites
Stage
to
1,
space.
RP1 load complete.
The satellites are safely enclosed inside the 17-foot diameter payload fairing, which is that large barrel structure at the top of the vehicle, the nose cone,
Look at the
right
colors
above
in
the
the sky.
second stage.
Florida
It's
sunsets
made
are
of a
beautiful,
carbon
man.
composite material, and it protects the satellites on their way to orbit. We'll jettison those fairing halves approximately 3 minutes and 20 seconds.
Because they're
into
the other
flight.
guy, Dish. How
Now,
dare
for
you?
today's mission, we've got 2 spacecraft
dare
on
you.
board on the second stage inside that fairing. Each payload
Oh,
will
nice.
deploy at separate
Now look.
times, about 6 minutes
They're
apart
stacked on
from
top of
each
each other.
There's a great view of the 2 mPower satellites on your screen. The fairing halves
Look at-
supporting
see
today's
those
mission
things right
are
there?
flight proven.
Solar
one
electric
half having
propulsion.
flown for its
Ion
4th time, and
thrusters.
the other having flying.
No,
excuse
it's
me,
not a TIE
for
fighter.
Its 5th time
Shh.
today. Now, next to the vehicle, we've got this large truss structure that's called the transporter erector. You will also hear that referred to as the TE or the strongback. We use that to roll the vehicle out to the launch pad and raise it into the vertical launch position. It also has the important role of routing the vehicle's fluids, power,
Ah,
telemetry,
Dish, how dare you.
and umbilicals from the ground system to the rocket and the satellites.
taken my
and that'll
childhood.
continue until Falcon 9
How dare
transitions
you.
into the final stages of the countdown when it transitions to internal power and ultimately clears the pad. At T-0, liftoff, we'll retract
Jackal.
the TE away in order to clear the way for Falcon 9's
Tanks are
descent.
pressing for strong back retract.
Okay.
You just heard a
moving the
call out
tanks up
there
to
that we're
flight-
beginning to
up to-
pressurize
hold
the
on.
tanks.
Moving the tanks up to flight pressures here to make sure that the flow rate going into the turbo pumps is correct. They also pressurize these tanks up so the rocket can actually stand. Rocket wouldn't be able to stand by itself. It needs the erector to kind of hold it up. Erect. It needs the erector to hold it up. Because the rocket is basically engineered to only be launched and going up into space when it has a full tank of gas. Basically, that's part of a whole kind of mentality that you have to have when you're building rockets. The less rocket that you put on your rocket, and the more fuel you put on your rocket, the further your rocket goes. So, there's no point in making Falcon 9 stand up by itself. Why would it need to stand up by itself? The only time it's ever going to stand up by itself is when it's fully fueled. So you pressurize those tanks to make sure it stands up. That's the only way it's going to fly. It's actually a really smart idea.
At the base of the strongback, we've got a hinge structure.
Bad
and we use
Jackal.
ground hydraulic systems to pull back the strongback to a fully reclined position that'll recline even further.
So
at
unlike the
T-minus 0
Vandenberg
mark.
launch that we saw this morning, unlike the Vandenberg launch, this strongback stays kind of right next to Falcon. The Vandenberg one actually goes backwards a little bit, and then the vehicle launches. This thing, when Falcon 9 launches, it's gonna get out of the way. It's called a throwback transporter erector. Those hydraulics, the blue right there, they're gonna pull, and the thing's gonna go flying this way.
Topping up liquid oxygen on both stages. We have about 1 million pounds of kerosene fuel and liquid oxygen at launch. And we continue
Stage 1, lock load
topping
complete.
up. There was a
Stage
call
1.
out there for stage 1 lock load complete. We continue topping up that liquid oxygen
finished
on
filling.
the first and second stage because we loaded at an extremely cold temperature.
What necessitates the different need for different types of strongbacks? Well, Bellum, it really has to do a lot with structure, but it's really about how the rocket goes together. Some rocket manufacturers opt to make a rocket that can't stand up by itself. A lot of rockets are made that way. So now you have to build a cradle for it. The transporter erector is not just something that kind of holds on to Falcon 9. There's cradle points on it that hold, you can't really see it, but right around where my mouse cursor is, just above that plume from the first stage liquid oxygen vent, that's a gaseous oxygen vent or a GOX vent for the first stage. You could see some infrastructure right there, and that's literally a cradle. They lay the rocket down, and then they roll it out of that hangar over here. It rolls down here, and then they move it upright. That's holding the thing. Falcon 9 really doesn't like being held sideways either. So it really comes down to how you want to engineer your rocket. That makes now you have to horizontally integrate, which is a little bit more difficult, right? It requires a little bit more equipment because, how are you going to get that thing onto the transporter erector, and how are you going to attach a stage? You got to kind of attach a stage when it's angled and then put the thing down. But this is much simpler for launching operations because you can roll the thing on its side. Compare that to like Atlas or like Vulcan or something. Those things are designed to just sit vertically. They can sit vertically by themselves, and Vulcan can be horizontal, and so can Atlas. They actually take it and they just stack it with like a regular crane, like a bridge crane, and then they roll it out on a mobile launcher. That makes handling the rocket a little bit easier, right? But you have to move the whole damn launch pad. This thing only moves half of the launch pad. The TE will actually attach to a reaction frame down there. The reaction frame is what the rocket bolts to, and that's what bolts to like the pad proper. If you could see the frame down there, it's kind of square-ish looking. It's behind the timer. But it really comes down to what type of rocket you're making. What propellants are you using? So, like, you look at a Centaur stage that's on Atlas. Centaur cannot stand up by itself. If you depressurize the Centaur and you had it stand like that, it would literally crumple under its own weight. Because it uses pressure. It uses internal pressure for structure. Like, think a soda can that's full, as opposed to one that's open. Really hard to crush it. But anyway, I'm going to shut up. We're going to get into launch coverage. Let's do this.
15 seconds.
So you're going to see a green flash down there. That's the pyrophoric ignition fluid
T-minus 10,
called
9,
T-tab.
8,
That
7,
starts up the
6,
fuel pumps
5,
for the rocket.
4, 3, 2,
Green
1.
flash.
Engines full power. And liftoff
All right.
of SES mPower. Go Falcon 9, go SES.
mPower is flying. Second Falcon 9 launch of the day. Good. Our second catch of the day.
Vehicle's pitching downrange.
M1D chamber pressure pump.
Everything's looking good there. Sorry, I didn't really feel the need to say anything.
Power
It
into
looks
telemetry
awesome.
nominal.
Falcon 9 has successfully
Sorry,
lifted
guys.
off from
Just
Space
looking
Launch
at it like,
Complex
damn,
40
that's
at
cool.
Cape Canaveral Space Force Station in Florida, carrying the O3B
Okay.
mPower
I'm
satellites
here, I
to
swear.
orbit. Here's a great view from the first stage, looking down at those Merlin 1D engines. Now, during the
Vehicle
ascent,
is
we have
supersonic.
begun tilting the engines. That's called gimbaling. And we've begun actually moving horizontally away from the launch pad in a maneuver called a gravity turn.
Need
We're
what?
still mostly going up. As you can see, the altitude
transporter
is
erection?
increasing. But we're also
Next
starting
cue.
to go horizontally away from the pad, and ultimately it's that horizontal speed that will get us to orbit.
Vehicle's pressurized all the way
I
up.
apologize, I just talked over the call out there for max Q. That is the point of maximum aerodynamic pressure and the highest stresses on the vehicle during the ascent.
Did Shiva just apologize for talking over the comms?
Now, the rocket needs to
Word.
go about 17,500 miles per hour
Detail.
horizontally
Second stage does that.
in order
Impact
to
shield.
avoid getting
Watch.
pulled back to Earth. So we'll be continuing to accelerate the vehicle in preparation
See,
for
that's
several
why we like
events we've got
SpaceX
coming up
things.
in about a minute. The first of those will be main engine cutoff, followed by stage separation, and then second engine start number 1. Now, main engine cutoff is where we shut down all 9 of these Merlin 1D engines in preparation for separation of the 2 stages, and then followed shortly after by
Not very
second
long,
engine start
Gorgeous.
number 1. We heard a call out there for MVAC chill in. That means we've begun to chill in the turbo pumps
MVAC's
on the
chilling.
second stage in preparation for full flow of the Merlin vacuum engine and ignition at about the T+2 44
What's
mark.
going on up there on the left?
So again, coming up, main engine cutoff, followed by stage separation, and then SES-1.
Whatever was going on up on the left there is something I've not seen. Max Q goes away, Gore-Tex, because the atmospheric pressure goes down as the rocket
Stage
goes higher.
separation
So
confirmed.
hypersonic watch. You'll see the green flash. Ready?
MVAC ignition.
There it is.
Great views.
Okay, good
Left-hand
upper
side of your
stage
screen
ignition
is
there.
looking up through the interstage where the Merlin vacuum is sitting. You can see that's now a first stage view
First stage is
of the
gonna
grid
use-
fins deploying. Right-hand side of your screen is that Merlin vacuum engine having started its burn.
It is happening.
It'll continue burning for about the next 5 minutes. Next major milestone will be
It's
deployment
not
of the
RTLS,
fairing
Jim.
halves. Now that we're high enough in the atmosphere, we can actually jettison that mass and
So fairing separation should be happening here in a moment.
Bearing separation confirmed.
There we go.
great shot. On the right-hand side of your screen is the top of the payload adapter. And on
Yep,
the,
there goes the fairing. They'll get those back.
sometimes we can catch the fairing halves jettisoning away.
So, something SpaceX cams taught me. We could see max Q happen in the shape of the plume. It seems obvious now, but I never realized it before. Yeah. So Gore-Tex maximum dynamic pressure refers to the compression load from the compression load that's induced on the rocket, basically because the rocket you can't move the air out of the way fast enough. The rocket fairing is pretty dang strong, and it's pretty aerodynamic. It's just a nose cone, right? But there are certain points during the flight where it just can't push the air out of the way fast enough. So when it can't move the air out of the way, when it can't move the air off the nose cone fast enough, what happens? You get high pressure on the top. You get high pressure. The air starts to compress against the nose cone. And that compression actually accordions the vehicle a little bit. It actually puts a compression load on Falcon 9, more than what it would have from those 9 engines at the bottom, right? So they call it a dynamic pressure because it doesn't stay that way. It's not a static pressure. It's not constant. It only happens for a second. Because as Falcon 9 goes up more, the ambient pressure goes down. So there's the pressure that builds up on the front of the vehicle because the ambient pressure goes down will actually go down with it. So max Q is really only referring to the point where the rocket, during ascent, where it just can't move the air out of the way fast enough. But as the rocket will eventually go higher, you know, and you know, the dynamic pressure will go down. It goes down to the point where they don't need the fairing anymore, right? That's when fairing separation happens. Now I know what people are going to ask. So why don't they just make a rocket that moves slower up into space? The name of the game is still speed here. It's not just necessarily about height. You got to accelerate. You have to accelerate. You have to reach a certain staging velocity, or else your second stage is Earth will pull it back down before it can finish accelerating. I'm sure people have done this in KSP, where you don't stage right and your second stage ends up tumbling and falls and goes into the drink. You know what I'm talking about? So they could try to come up with a slower ascent profile, but that slower ascent profile, you would minimize aerodynamic compression loads, but gravity's still pushing down on you at a constant. If you don't accelerate fast enough, it'll pull that second stage in. Even if it has enough fuel to circularize, to get up into space, it'll still pull it right back down. Great sunset over there. What we're going to see now is the entry burn from Falcon 9. That Falcon 9 first stage came back from about 80, 90 miles up, well, actually about 70 miles up that way. It is going fast enough to experience some re-entry heating. So what it does is it fires the engine to get that re-entry heating out of the way. Watch, the engine's going to pop off right now, and the rocket exhaust is enough to push the plasma that accumulates from compression heating away. Supersonic retropropulsion is what it's called. Awesome. My favorite part. This morning's RTLS in Vandenberg broke some sound vehicle windows on the next street over from me with how loud it was. Excellent. Excellent. Fighting plasma with fire. Yep. I was here when he said it. Second stage is looking real good here. Say it slow, say it slow for you. Supersonic retropropulsion. Yep. It is the best speed metal band name ever. Supersonic retropropulsion. Yo, that new SSRP album dropped, bro. I know, man. It's free real estate. Hat. Ugh. And at first I can actually see the fairing separation. Nice, kill. Anyway.
Next major event
killing me. You guys are killing me.
Is actually shutdown of the Merlin vacuum engine
Stage 2
that we
FTS
see
is safe.
on our screen.
Stand by for second stage engine cutoff. What we want to hear the flight controllers say now is nominal orbital insertion.
Now the Merlin engines are
We're
optimized
looking for an NOI.
thrust in.
MVAC shutdown.
Okay.
They're optimized for thrust in the vacuum of space. They actually have an extremely long nozzle compared to the Merlin 1Ds. We had our call out there for shutdown on the
Nominal orbit insertion.
Good.
on the Merlin vacuum engine.
Next step here is
as
that
well as a
landing
call
burn.
out of nominal orbit insertion. Now it sounds
Hey,
like
nice t-shirt.
we're
Oh, thank
having
you.
a little bit of telemetry issues with the first stage. Should have started its landing burn at about the T plus 8 minute 24 second mark.
Expected loss of signal, Cape.
They have an expected
So
loss
the landing
of
burn
signal.
sequence, we start a single Merlin engine on the first stage,
There's the ascent plume. See it?
and by now
That's
hopefully
the
we would
clouds,
have
that's the
landed
exhaust that it left
on
over.
our burn ship. We'll see if we can get some more information
Yeah.
from the launch team once we get telemetry back.
You saw it, Dish? Nice.
So at this point, the mission
Worm.
is not over yet. We've just completed
Nice
the
jellyfish,
first
dude.
of 3
Oh,
burns
you
on this
got
Merlin
the
vacuum
fairings,
engine
too.
on the second stage. We're in our first parking orbit. Our next burn coming up on the second stage will be coming up after this coast phase. We'll ignite for a second time for a short burn.
Oh, guys, I'm sorry. I forgot to run the ads so people wouldn't have pre-rolls when they came in. My bad. Here. Dude, I'm gonna... Here, we'll do this. Sorry about that, fellas. I'll get you a sub so you don't have to worry about it, dude. Dude, I hate ads. I am willing to lose money so you do not have to look at ads. I will be straight up with you. I hate ads that much. Even if it hurts my pocketbook, I still don't care. I hate ads so much, dude. Yeah, Knight, that'd be cool, right? I don't know what's going on with that first stage. Let me back it up a little bit.
In the meantime, enjoy the space tunes.
I really didn't have to do that. No. Dude, it's all good. I hate ads that much, man. Dude, frick ads. I can't stand them. These are commercial communication satellites, Koopsie. Oh, it's horrible, Valk. Yeah, and they're double dipping, too. You have to pay for a service on top of that.
Discovery, go at throttle up.
Neil. Get to Sevakira knob.
Discovery, go at
Laser
throttle up.
drifter? Yeah, I hate that, dude. I didn't hear what they said about the first stage, guys. Did we hear them say something on the loop? I was talking about how much I hate ads.
Discovery, go at throttle up.
Hey, Visceral, 9 months. Thanks, buddy. How big is the gas pedal on a rocket? Well, the computer's controlling it, AOD, but if there was a gas pedal, it'd be one of those big foot pedals, you know what I'm saying? Last word was loss of signal on the booster. They just said no signal. That doesn't mean it didn't land, guys. Falcon 9's guidance system to come down and land on the drone ship is a closed loop system, meaning it's not being remote controlled. Falcon 9's computers are looking for the drone ship. There is a radar that will bounce the signal, so this could be a telemetry issue. It could be just the antennas on the drone ship aren't working right. So we'll hold and we'll see what's going on.
Expected loss of signal, Bermuda.
Okay, stage has an expected loss of signal from Bermuda. They've gone over the hill. There was one a couple years ago, Tessa. Yeah, yeah. Well, hopefully there's less ads. Yeah, Bill, I'm with you on that one. The fact that we don't have any control over it is very annoying. They didn't enable tracking stations, that's right. I know how to fix that problem, Jim, if they need it. Does Falcon 9 use latitude and longitude coordinates to land, or do they use a laser fired from the ship? It's a downward-facing radar, Badger, on Falcon 9, believe it or not. Now, that isn't to say that Falcon 9 doesn't have a...
Stage 1 landing confirmed.
Oh, sweet! Flight controllers just said Stage 1 landing confirmed. All right, show us the picture. That's what I'm talking about, baby! Just an antenna problem, guys. We are good to go. So what they're doing right there, all that stuff, actually, that's a lot of residual. So all that stuff that's coming off the booster, that vent stuff, is them purging out the engines. They want to get the oxidizer out of the engines because it'll rust the engine from the inside out. Liquid oxygen oxidizes things. I know, right? Crazy story. So they're shooting helium through the engines, through all the cavities in the engines to get all of the gaseous oxygen out of there, so they basically save the engine. That's what all that stuff coming out was. Now on the ground there was some residual liquid oxygen that the engine puked out when it was done. Think of that like a garden hose. There's water left in the line even if you shut the water off. That happens. They go to shut the taps off on the engines when the thing lands, and you get some residual propellant coming out, and it looks like it puked it out over the ground. But it didn't catch on fire, so that's the good part. Yeah, Jackal. Oh yeah, big rainstorm. Forge, everything looked okay. It looked like I did see something weird on the interstage during ascent, left side of the interstage, but it seemed okay. Hasn't it been raining for like the past 5 hours? Oh yeah, it's a muddy mess out there, Jackal. When I went and got the package from my doorstep, dude. Oh yeah, muddy mess, dude. Watch right before the burn. Lots of fire and parts falling off, or was that your phone resolution? Right before the burn. No, I don't think so. Can you show what you're saying you'd never seen before? Yeah, we got some time here. Let me replay. I'll show you. So this one could be chalked up to atmospheric conditions, and that's what I think it is. But if you look right here, I don't ever remember seeing something like this. But then again, every flight is different because the atmosphere that it launches into is different every time. I did, Blinga. We're good to go.
Down all 9 of these Merlin 1D engines in preparation for separation of the 2 stages.
Okay,
and then followed shortly after by second engine start number 1. We heard a call out there
like,
for
see, that is what you usually see, but watch right here.
On the second stage.
Couldn't that be the RCS? Well, Blue, the RCS is right there. See, look.
Merlin vacuum engine and ignition at about the T+2.
I don't ever remember seeing that the MVAC chill do that.
Main engine cutoff, followed by stage separation, and then SES1.
I think it may have just been the lighting conditions combined with atmospheric conditions. So what that is the Merlin vacuum. Okay, all right, pause for a second. See those lines right there? Though what they have to do, and this is what Shiva was talking about with what's called Merlin or MVAC chillin'. All right, so it's not called chillin' like, man, I'm chillin'. Like, it's called chill in. There's two words. So what they're doing is, see all these pipes and stuff that are up here? Well, behind this space blanket, there's more. The fuel pumps for the rocket engine are behind that. They're called a turbo pump. All right, well, okay, what's a turbo pump? All right, think turbocharger from an automobile. So you have a turbine, a gas generator with a turbine wheel. The gas generator makes an explosion. The explosion goes through and spins the turbine wheel, just like exhaust gases from a car would spin a turbocharger. Now, on a turbocharger, you have an air compressor at the front. So you have your compressor housing. It looks like a snail. Happy snail times. Turbskis. On a rocket, they took the compressor off and they put a fuel pump on it instead. That's how the rocket engine actually fires. That's how they deliver the fuel. The fuel pump delivers the liquid fuel and oxidizer into the injector plate on the rocket engine. Basically, it's your fuel injector, just like it is on a car. And that makes the explosion inside of the combustion chamber. It gets squeezed through the throat and goes out a big venturi, which is the nozzle, right? So when they chill down the engine, basically what they do is they prime it. It's like prime starting a lawnmower. You want to get the carburetor full of fuel before you go to start it. You want to get the engine full of fuel. You want to get those pumps full of fuel. Because basically when you want to start the engine, you want it to go right away. That's a big one. You don't want to tell it to fire and then have it backfire or something. That can create what's called a hard start condition. Hard start conditions usually don't end well. While we're on the subject of car analogies, have you guys ever seen a carburetor backfire? Yeah, that, but with rocket engines. Explosion, not good. Don't want to create a hard start scenario. So they trickle the propellants into basically when they turn those engines on, it starts delivering fuel right away. It's basically, it'll fire right away. The other reason why is that Falcon 9, the Merlin vacuum uses it's semi-cryogenic. Don't get me wrong, the first stage engines are also semi-cryogenic. Dude, it is pouring outside right now, by the way. And it's super windy. That's what you guys are hearing. So when you, where was I? So because it's semi-cryogenic, it's using RP1, which is basically diesel fuel. It's like an aerospace grade diesel fuel. It's diesel fuel's airplane cousin. So it's like Jet A, like what you'd find in a passenger plane, like a 737 or an A320 or something. And then they're using liquid oxygen. Because there's no oxygen up in space, you got to bring the oxidizer with you. You got to bring the oxygen up with you. So that they do that, but the oxidizer, in order for oxygen to exist as a liquid, it has to be super freaking cold. So they're basically thermally conditioning the engine by trickling the propellants in. And basically, you don't want to flood the rocket engine because that'll just dump fuel all down here. You don't want to do that. So they have vent lines. Instead. It flows through the turbine machinery, right? And then it flows out these vent lines. That's what those things are right there. And that's what we're seeing right there. It's just being backlit because the sun is over here. And I think that's normal. It's just we haven't really seen it so much because the sun hasn't been at this angle during an ascent ever.
So again, coming up, main engine cutoff.
It is raining a lot, Cubat. Yeah, it's raining a lot. So, Goalie, you said you saw something during the entry burn. Let me take a look.
On the Merlin vacuum engine, as well as a call out of nominal orbit insertion.
Yeah, Dama, you got a picture of it this time?
It sounds like We're having a
Yeah.
little bit of telemetry issues with the first stage. Should have started its landing burn at about the T plus 8 minute 24 second mark.
So
Stage
that flash that you just saw right there, that's the nitrogen attitude control thrusters. The ACS is how Falcon 9 moves around when it's up in space. And then once it starts getting back into the atmosphere, the grid fins start to take over. The freaking waffle iron right there. All right.
one FTS is safe.
There's a lot of re-entry heating going on down there, but I think it's just the lighting conditions. And I started to see some plasma accumulate on the right grid fin, but everything's fine. That looks fine to me, goalie. I'm switching us back over to live, guys. Stage 2 in 20 minutes. Stage 2 and the two O3MB power satellite or O3B mPower satellites are already over, I think, Liberia, if I had to guess. 20 minutes across the ocean. How long did that take the Pilgrims to do? Nice, Minuteman. Right on. That was too cool. It's awesome when you see it because you're like, oh, I'm not going to say, oh my God, there it is. You know? Took the Pilgrims like 3 months. We can do that in 20 minutes nowadays. 2 hours if you're on a regular, well, we used to be able to do it in 2 hours. Shame, Tesla. Shame. I wasn't expecting it this far north and inland. Then I had to check here if I was seeing good stuff or bad stuff. Right on, Minuteman. Where'd you post that? Oh, okay. Let me see. I want to see. If you don't mind. Oh, dude. Yo. Are you kidding me? Bro, what? That's a really good shot, dude. Bro, it's clear as day. All right. Now we're talking. That's pretty cool, man. The jellyfish, man. Yeah, what created that really nice flow phenomenon is the sun backlighting the plume because the sun's going down in the United States right now. Well, I'm a little bit further east than Florida. A little bit more north, a lot of bit more north, and a little bit more east. Guys, the sun goes down at like 4:30. It's still light out somewhere in the U.S., I swear. Your shot repost. Let me see, Dish. Try 2:30. No, I'm good, man. Dish, those are good, man. Those are very nice. Let me see. Yeah, I mean, I looked at these a little bit ago. I'll share them with chat. Dude, oh, see what I mean? What a nice shot. Yeah, exactly, Havix. You commute you go to work in the dark and you come home in the dark, man. Oh, dude. Yeah, Dish got the fairing separation. See that little thing right there? That's the fairing. And see that little thing over there? That's the first stage. A little blip. You can barely see it, but... Actually, that might be the first stage right there, and the fairing might be there, I think. Yep. That is the first stage. There's the fairing, or at least one of them. Beautiful. Great shot, man. Wicked. Wicked. Very nice. What car's the abort? Okay, they have an AOS through Gabon. What caused the abort launch earlier? I just got here. Abort? Who aborted? Yeah. Oh yeah, BD. I was here for that, dude. I don't know why you subject yourself to that, but okay. Aramel, thank you for the reset, by the way. 10 months. Appreciate it. I don't know, Mycon. No idea. There is a launch tomorrow at 4:30, Novaraptor. I will be here for that, but I am taking Saturday off, except for the launch and GTA. We have Hunt the Streamer tomorrow, if I'm remembering correctly. The trajectory is mission specific. That's right, Kroggy. Yeah, sometimes it goes due east, like what it did there. Sometimes it goes northeast. Sometimes it goes southeast. Sometimes it goes south. The rockets launch in different directions for different orbits. What you're referring to there is called a flight azimuth. Flight azimuth uses the same compass as like an airplane. So if your flight azimuth is 45 off the pad, you're going northeast. Keep in mind that's your different flight azimuths, and this gets a little bit annoying. It's a little. Oh, I'm gonna shut up.
Coverage of the Falcon 9 mission carrying the O3B mPower satellites for our customer SES. Now, Falcon 9 launched at 5:48 p.m. Eastern Time from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. We had a successful liftoff, main engine cutoff, followed by stage separation and a first burn on our Merlin vacuum engine.
No, not at all, Alex. I'm going to play Minecraft on Mondays from now on. I'm putting Mondays back on the schedule. Minecraft on Mondays.
Over the coast period that we had a successful first stage landing. That marks our 157th recovery of an orbital class booster and the 8th landing for this particular first stage. Now we're coming up on the second relight and shutdown of our Merlin vacuum engine, or SES-2. Over the coast phase, we also heard that our telemetry and real-time telemetry may not be available for this burn, so we're going to keep an eye out and see if we can get any data during the burn.
So
that burn expected to start in about 5 seconds.
There has been 2 launches today, Neb. There were supposed to be 3. The third one they postponed.
Second engine startup.
Okay. The third one they postponed.
So call it on the loops there for second engine start number 2. This is a 30-second burn.
2.
30-second burn. This is raising the apogee, or the highest point of our orbit, with the mPower satellites.
Note how the numbers over there aren't changing? It's because they don't have signal with the vehicle right now. That's right, Alex. Except for GTA and rocket launches during the weekend. Nice, Core.
And second engine cutoff number 2 should be coming up shortly.
Shutdown.
There's a call out from the ground operators. So we'll be taking a look at the performance of the burn to confirm that we're in the expected orbit.
No, Neb, don't worry about it. You scared me. I'm like, wait, what? All good, man. Yeah, that was a Starlink mission. That mission's going to go off.
Now, this is the second of 3 expected burns. We have one more scheduled.
Yeah.
About an hour and 20 minutes from now. And conversation on the loops right now sounds like we're going to do a quick data review, make sure we're in the target orbit.
That you were given Christmas cookies, and half of them were supposed to be for me.
So we'll come back with an update once we have that information. As I mentioned, the third and final burn of our second stage should occur in about 80 minutes, around the T+1 hour, 49-minute mark.
Where are they?
They're on the toolbox.
So we'll have an update for you then on the performance of the second burn. In the meantime, we're going to leave you with some more views from space. We do have additional ground stations, as well as some space jams, so we'll see you back then.
Azimuth doesn't mean inclination. That's what I was trying to say. I'm in danger! I did warn you. Baby, come here.
Discovery,
Bree,
go at throttle up.
Come here. Dip it in the coffee. Trust me.
I need you to open this. I took half. What are you gonna do? Bring him home? Bring him inside later?
Yeah.
Oh.
Why do you think I left him out on the toolbox and not right in front of me? Here. Have this. Trust me. That's what I mean. I put him out on the toolbox because I'm like, nope. I cannot take this with me. I will eat all of these.
Okay. Well.
But chat decided to be a jerk about it. I only had like, I think I had 4 of them.
That looks about right. I'll put these back then, as long as you promise to bring them home.
I will, because I'm a good person and I like sharing. I like the frickin' jabroni in chat that threw me under the bus. Thanks, my back hurts because I got ran over. You throw that away from me, baby. Thank you. Love you too. You can take the box inside now if you want. I don't want any of those near me anytime soon.
Alright, I'll take them. You know what we should do tomorrow morning? We should check your PO box. And then go shopping.
Okay.
Just thinking out loud.
I know, Alan. Ridiculous. Tessa, if I ever meet you, I'm kicking you in the junk repeatedly with a steel-toed boot. Just so we're clear. I think you should reopen the back door for quick escapes. Yeah. It should be out of the Portland now, KJ, but nothing. I haven't heard much. Go back to T plus 2820.
Now, this is the second of 3 expected burns.
I agree, GB.
We have one more scheduled about an hour and 20 minutes from now. And conversation on the loops right now sounds like we're going to do a quick data review, make sure we're in the target orbit. So we'll come back with an update once we have that information. As I mentioned, the third and final burn of our second stage should occur in about 80 minutes, around the T plus 1 hour, 49 minute mark.
All right, well. Wow. The overdriven sound, though. It's a first for SpaceX. I think it's just a telemetry loss. I think it's just a telemetry loss, Phil. Yep. Yeah, they just didn't have a good signal. They reacquired through Diego Garcia, if I'm looking at this right. Man, look at the chunk of solid oxygen right there. So, just like the first stage engines, guys, they gotta purge out the second stage engine between burns so it doesn't rust from the inside out. Liquid oxygen will rust something that fast. It's like worse than salt. Down here, salt is a way of life. So what they'll do is at the end of these purge lines here, Geo Jim, thanks for the raid, buddy. A rocking raid. More geology streams, huh? Nice. 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 So out of the purge lines there, when they shoot helium through the engine to purge it all out, all that oxygen gets out and it gets exposed to the vacuum. It freezes. Yeah. Yeah, Tessa. Yeah, just no accountability. It's fine. I perused it, Phoenix. I haven't read through the whole thing just yet.
Discovery, go at throttle up.
Hey, Just Space. EJ, finally able to tune in after a crazy semester. I have some amazing news. You're pregnant. No. Rocking raid! Geo Jim, thanks for the raid, buddy. Appreciate it. Are you Pargnet? I was always curious about how they purge the engines out. Is there a separate tank? There's helium tanks inside of the fuel tanks. See, man? COPVs inside of the fuel tanks. Tanks inside of your tanks. What's up, dog? Can you get Pigonat with rocket? Well, I don't think we're in a drought anymore. Yeah, I think you're right. Just because you have a job. You're moving to Nolans to work on SLS in Michoud. Whoa! When you graduated, of course. That was my next question, Just Space. I'm like, you better finish your degree or I'm slapping you. That's awesome, man. That's awesome. Just Space, we gotta hang out, dude, before you go. You gotta chill. I will buy you a Sammy. A couple of Sammys on me, man. Excuse me, I gotta say that. Let me revert to the local diet. I gotta buy you a couple Sammys, guy. We'll go to the cask. Buy you a couple Sams. It'll be great. Excuse me. Now back to your regularly scheduled programming. Get you some of that Sam Winalaga. Your cousin from Boston. I know. Are you free between January 9th and the 15th? If so, you could come by and see the rocket before you drive cross country. Sure. I will make plans. Dude, seriously, shoot me a message. We'll make plans. I'm in. Let me see. What's the 9th and the 15th? Hang on a minute, Chief. I was going to hang till I saw that gross nonsense on the streamer's head. Guys, there's a Bills fan here. I don't know if you know. 9th to the 15th. Yeah, dude. Maybe on the 14th. We'll talk. That'll be sweet, dude. Rocket Lab from Wallops is on Sunday, Bill, as far as I know. You had a Hap winner at your local pizza place last night. Wicked good. Hap's good stuff there, man. Oh yeah, Just Space, you'll want to hang with Cyborg. Cyborg, you'll want to hang with Just Space. You guys do the same thing, by the way. Now Kith. Wait, what? Sorry. It's not weird now. It's weird. Okay. No, where are you going? We'll be fine, T-Man. Do you think that we could build an Iron Man suit in real life? I'm such a fan of the suit that I want to become an engineer. You'd need to power... So, Liam, sure. Of course you could. You need an arc reactor. That's what makes the Iron Man suit not work in real life. You need an arc reactor. You need something to generate that energy. Sure, of course you could. We don't have arc reactors. That's the difference between Iron Man's universe and ours. Gif, assemble the men.
Acquisition of signal, all leaves.
Nice, Forge. Now, Liam, I'm not gonna sit here and say that an arc reactor can't be made. Of course it could be made. But we actually very recently came close. The closest we've ever come to making an arc reactor. The Livermore National Laboratory made a sustainable fusion reaction. They weren't able to do anything with it, but they had a net positive energy fusion reaction. Basically, they made a fusion reaction happen in their laser accelerator, and they got more energy out than they put in. which is excellent. That is really good news. Oh, look at that thing. That chunk went into sunlight, and it immediately started turning to gas. Did you see that? So, Liam, we're on our way. It's going to take a lot more research, though. A UFO! No, seriously, look at that chunk. Let me back up a little bit. So that chunk came off, and the second it got introduced to sunlight, it started turning back into gas. Look, see? And then sunlight and... Crazy part about that is that it outgassing like that is actually going to push it in that direction even more because it's turning to gas, and that's gonna redirect it. Legit miniature comet. Bingo. That's really cool. So what did I tell Boeing to make them go faster? Block buy. Yeah, just base. Block buy is what you want. Iron Man age soon then? Well, let's figure out how to get power out of a net positive fusion reactor, Jackal. Basically, they just, that laser fusion thing that Livermore, what the heck? Coming over sun. The laser fusion reactor at Livermore basically only made a bunch of heat. They're not really sure, they haven't worked on like the scavenging system, like how it's going to generate power. That's going to take some time. And then miniaturization after that is going to take even more time. But yeah, Liam, I mean, if you want to get into engineering, that's mechanical engineering to engineer a reactor like that. Tony Stark was a mechanical engineer, if I'm remembering correctly. That's the kind of stuff ME degrees will teach you. Look at the Earth. Dude. I mean, the fusion thing is sweet, guys. Yeah. Envy, the fusion is excellent. We just got to figure out a way to make it constant. So the pellet, they'll drain the pellet. And actually, Envy, we were talking about it the other day. I was talking about having an intake and exhaust valve to intake new pellets and exhaust pellets and have multiple of these laser accelerators in a row and make it work like a car engine. And it can have the heat move a piston up and down. You don't want an internal combustion fusion engine? That's like the Warthog from Halo, man. That would be amazing. The current thinking is to flow water through a channel around the outside of the tokamak, but that's literally decades away. Yeah.
Expected loss of signal, HBK.
How can you handle Robert Downey Jr.? He's too cringe. I don't know. I'm not really that big of a superhero fan, guys. Just a nerd. The technology, here's the technology. I'm simply asking you to make it smaller. Yeah. I gotta get my phone. My phone's still out there. I'll be right back. Let's see. If we could harness that power, lightsabers would exist. Yeah. If you could go to the Marvel Universe, what character would you want to be? I'm not the biggest Marvel fan, T-Man, but it would probably either be the Cap or Iron Man. Either one. Makes me curious, how did Tony Stark figure it out? How do you figure out how to miniaturize an arc reactor? Well, he was fighting for his life in a cave when he got kidnapped by a bunch of rebels. How does the gas become ice? Because, Clayton, when you're in the sun's shadow, it's freezing. Like freezing cold. When you vent gas out the side of the spacecraft, it's not that space is cold. Space is nothing. Don't get confused. But if you vent... Yeah, that's nitrogen, solid nitrogen coming off the other thruster over there. Either that or they're purging down the stage. I'm not exactly sure. Basically, when you have super cold propellant and you vent it as a liquid or a gas into the vacuum, the temperature drops and it immediately solidifies in that second that the temperature drops, and then it just stays ice until the sun comes in. When the sun will light it up, it'll heat the thing up, and you can't move the heat anywhere, so it'll just melt. It'll turn back into gas. I like my internal combustion engine fusion idea. Can we do that? That's a good idea. The ball that they used to get the fusion reaction was made out of tritium. It's very, very rare and expensive. It was a proof of concept, still progress. Okay, Deathy Poo, I got an idea. Use nuclear reactors to do alchemy and make more tritium. Yeah, I said it. How does SpaceX keep the prop cold in space when the sun hits the rocket? Pressure. Pressure inside of the tanks, Jackal, is how they do it. But thermal's a big deal. There's a reason why most rockets are painted white.
Acquisition is
Yeah.
Western Australia.
Ah, they got a signal through Western Australia, mate. You could do that in a fusion reactor itself. So Acolex, you could like do this, like unlimited power. Unlimited power. Bro, that's genius. Well, stage is venting something up there on the right. Of course, it was so simple. There's an experiment in the world. Whoa, you getting sick yet? There's an experiment in the works to turn deuterium in the fusion reactor into tritium. We should do that. Everything is fine, Hypersonic. Yeah, she landed. I'm just watching the first stage go around and do its thing. We should do that, Tessa. That seems like a good idea. Now plumb your exhaust into your petrol tank. Hey, Heavy, you ever heard of exhaust gas recirculation? You could do that with a car motor. EGR, baby. Now we just need to take a fusion reactor and put it into a spacecraft. Eventually, T-Man, yes. What is it taking up? Clayton, these are O3B mPower satellites. They're 2 commercial medium Earth orbit communication satellites. Oh, with the retro encabulator. Yeah. We need the sock drawer. That's right. Yeah. Adrian, yeah, absolutely. Landing was fine, Artyom. Yep. The view you just saw is what Polaris Dawn will see. Very nice. One day the U.S. Navy will have fusion-powered aircraft carriers in space. Precisely or not. Whoa! They're doing a lot of reorienting on this stage here. Animal, that's what I'm talking about, dude. Figure out a way to get the fusion reactor to work. Guys, with enough energy, you could turn goat piss into gasoline. Blues Brothers quote. I don't know, T-Man, maybe you should teach them. Barbecue roll, yep. Okay, Alex. Yeah, and Alex, on Mondays. Mondays now. With enough energy, you can do whatever. When can we fuse copium? I don't know. I heard that hopium is more potent. You get a more potent yield from hopium than copium buster, but you dick. Man, I'm running out of hats. Like 30 hats on the floor, man. Copium and salt. Down here, salt is a way of life. Walls are salt, this floor is salt, the ceiling's salt, and even to an extent the air is salt. Everything's salt. You know, you breathe the salt. Everything's good, Boxy. Yeah, we're just coasting out to a third burn here. Clayton, you've been thinking about this for a while. If satellites are getting so advanced, why aren't they not using some of them to study the seafloor to find shipwrecks and lost cities? They do that already, Clayton. Yeah. Jason 1, Jason 2, Jason 3, and SWAT. A satellite that you're literally describing. I mean, this is for ocean topography, so it's water levels, not necessarily seafloor. It was literally launched this morning. Yeah. You just saw all these flavors and you just choose salty. Did you even try it? Cool. Down here, salt is a way of life. Look at that cable management, guys. Spacecraft always have the best cable management. Let me see. All right, let's take a look. What do you got for me? Hey, Tren. Congratulations on this SWAT coverage. Oh! Yeah! Very nice. Very nice. Very nice. I like. Hey, Tren, you see that? Rockets are pretty cool. Hey, Tren, the cast that we got on our end was pretty cringe. Someone, you know, it's almost like, you know, I could do a better job or something. You don't like rockets? Oh, that's a shame. That's a shame. Rockets could be a good friend to you. That rocket was upside down. Engine test stand. I love the engine test stand is ratchet strapped to the ground, baby. Atran, I've heard that rocketry in getting into that industry will bring you to fun and exciting places where you get to explore and hike mountains to be more in touch with nature. So I've been told. I don't know who told me that. Kind of a weird question, but do rockets ground their electrical to the body like a car, or run power and ground wire? That's a good question, Boxy. That's actually a really good question. So what I like to do is I could say they ground out, or I could say they use direct current, like through, you know, with a positive and negative. What do you think? What do you think's lighter? Seriously, because think about it with a rocket. It's mass. You can use some logic extrapolation and kind of figure that out. What do you think? Where's this thing going? Medium Earth orbit, Italian guy. You read my bio. No. No. Now, what would you do? You'd think that, you know, positive and negative would be good. So if you ground out on the frame like a car, that's probably a good idea. But do you remember that the outer frame of the rocket is also the fuel tank? Do we want to arc an electrical signal through a fuel tank like that? Yeah, that doesn't seem like a smart idea. They're two wires, but it does depend. It depends on what it's doing. Like if you're using a separator, so sometimes they have like an explosive bolt. An explosive bolt can just ground out because once you just make the connection, it grounds out. And pfft, there you go. It depends on the system, dude. It really does. But ideally, you're trying to save mass, right? That's why cars did that back in the day, because it's way less complicated if you know, your negative terminal on the battery, grounded out right on the car, and the engine is grounded out right to the frame. Done. All you got to do is just run the positives everywhere, and that's it, right? It saves a lot of time, saves a lot of mass, lot less stuff to move around. Rockets are the same way to an extent, but there's certain times where you really don't want to do that. You got one, Cyborg? Okay. That's what I was thinking. Kind of like the refuelers I work on compared to the troop transporter vehicles. Bingo. There are certain times where you just it really comes down to what you're trying to do. What do you got for me? Oh, no. We need sound. Oh. Bless you. Oh, here comes the boom. Fusroda! Wow! Hi, you turned 39 today, feeling old. It's just a number. Clip that! Fusroda! Is Starfield? I was gonna say Starfield. Are Skyrim memes still good? Is Fusroda still funny? It was funny back in the day. Fusroda! Yeah, interesting, Tessa, right? Oh, spinning her around. Still funny? Alright, cool. I used to build spaceships like you. Then I took a booster to the face. How are you still alive? Oh, for safety reasons, make sure you got a good ground from the block to the firewall by the pedals. My brother had a bad ground and the gas pedal wire became the ground and melted and froze in place and stuck while driving. Oh, yeah, no, I actually, when we did the wiring, Sleepy, I redid it. I'll show it to you sometime, dude. As long as Bethesda keeps releasing Skyrim in a new edition, it's fine. Hadouken! Yeah. Is Fusroda just Viking Hadouken? Anyway, Cyborg, that's cool. Good stuff, man. So, with that solid rocket that fired from Cyborg, if I looked at this right, and I could be presuming, and screw me for doing that. If I'm wrong, laugh at me. Please don't. It'll hurt my feelings. It won't. You saw that smoke that came out? With SRBs, what they do often, it's not just flip the thing on and go. They actually kind of stage it by heating up the propellants for a second, and then it fires. So you see a little bit of black smoke on big SRBs, like the attachable boosters for like Atlas or Vulcan or something. You can see them pop like that. Or if you watch a Minotaur launch, same thing. You see a little bit of smoke come out because they heat up the propellants for a second and then light them on fire. That's correct, Jackal. Barbecue rolling. Yep. They're literally slow cooking the stage. And Jackal, yeah, you asked about thermal. That was you. Yeah, they're rolling it to manage the heat. Apollo did that. Sort of right. Our sustainer booster lights up immediately because we have a head-end ignition system. Oh yes, a head-end ignition system, please. Yeah, I know what that is. Yeah, totally not looking up right now. What? They wouldn't let me put a bigger igniter in it, unfortunately. It should have been more instant on. Oh. So I'm half right. Hey, 50 isn't bad. That's passing in some places.
Acquisition of signal, Guam.
AOS through Guam. It's not too complicated. It's just a smaller motor that lights a bigger one. Oh, okay. Yeah, that's kind of like what I said. Actually, Just Space don't. The Space Shuttle SRBs use that, don't they? They have an igniter that lights a bigger igniter that lights the rocket. Yeah. Yeah, Miniman. An hour in, they've gone around the world and they're back to Guam. They're closer to the launch site than when... They've almost done an entire orbit. It's about 90 minutes to do an orbit at this altitude, but it's going to go up because they're in an egg-shaped orbit. See it going up? It's going to take a little bit longer, but yeah, an hour and 30 minutes is enough to go around the world with a rocket. Oh, that's awesome, Dragoon. Inorganic chem. Right on, man. Whoa, slow rolling the stage. Off topic, why did the N1 have grid fins on the first stage? What do grid fins do, Milo? They're a hypersonic control surface, right? N1 needed that because it needed stabilization in the hypersonic regime. Keeps the center of pressure low on the first stage towards main engine cutoff. They never got that far though, but cell processing. Oh hey, at launch, guess I missed this. I forget if you were here this morning. This is the second Falcon 9 launch today. Although the Space Shuttle booster is a bit weird because it's fissile grain is at the front of the booster, whereas ours is at the business end. Interesting. Around the world's in 80 days to around the world in 80 minutes. Pretty much, Buster, yeah. Rockets, man. Buster, I've reduced my whole love for space flight to, I just like going fast. I just like things that go fast. Rockets go the fastest. I want to go fast. Have they ever done 3 launches in a day? They were supposed to this time, Manu, but they didn't. Drop shipping, but with rockets. We've seen this already, goalie. It's like watching a freight train derail. It just gets worse and worse and worse and worse. The F-35, man. Oh, God. I will never financially recover from this. Nice, Night Viper. That's cool. Yeah, Tessa, I know what you mean. Yeah, the manifold. It does look like it, doesn't it? This is what it should have been, but they didn't want the case to get blown up with too big of an igniter. Let me see. Oh, very nice. So SpaceX doesn't warm the fuel with nozzle heat. Not with these engines, cell processing. The Merlin series of engines are gas generator. They're a gas generator engine. It's about as simple as you can make a rocket engine that uses like a turbo pump. Now, there's a little bit of a difference between Merlin Vacuum and Merlin 1D. Merlin 1D takes the exhaust from said gas generator and just dumps it overboard. The Merlin 1D vac has a film-cooled nozzle, meaning that the exhaust from the turbine machinery goes into that manifold right there that has all these flanges on it. See this? It goes in there, and it provides a thermal medium between the nozzle and the hot rocket propellant. Now, I know what you're saying. Jet engine exhaust, the turbo pumps are basically a jet engine. Maybe you're not saying that, but the exhaust is hot, right? And the answer is yes, of course it is. It's not as hot as the rocket. It's not as hot as the rocket exhaust. Jet engines have hot exhaust. Rocket engines have way hotter exhaust. And the turbine machinery on this thing is literally a jet engine, but instead of having like a fan or a propeller or a helicopter blade attached to the front, it has a fuel pump attached to the front. And the exhaust from your turbo pump, turbine, fluid impeller, turbo pump, gets dumped into the nozzle there on the Merlin vacuum. The reason is because you have to find a way to keep the nozzle cool in the vacuum. It's one of the main convergences between Merlin 1Ds and Merlin vacuums. Two different engines nowadays. Something like that. Oh, there you go, Forge. Oh, yeah, okay. I see it. Aquash, yeah. Neutron plus H4. This is getting into stuff I don't really understand. Whoa. Cool. I think deuterium might be the best bet. Aqualux, yeah. The tritium is too expensive. You gotta find a way to have it work with deuterium. Merlin D's got him. Cool. Was wondering what the ducting was for. Yep. Mm-hmm. So yeah, these engines are about as simple. Merlin engines are about as simple as you can get. Like I've been following SpaceX for a good while. So I've missed probably out of like 180, maybe 190 Falcon launches. I've maybe missed 5, maybe. Yeah, like maybe 5. Dude, back in the day when Falcon 9, so this was about 10 years ago, when Falcon 9 was just coming into play and like SpaceX was trying to make bigger rockets, the idea was just to keep the engine as simple as freaking possible. Now, the Merlin engines, in terms of fuel delivery systems, have about as simple of a system as you can get. You have a little bit of RP1, a little bit of LOX, combining a little bit of liquid oxygen, combining in a gas generator, and that spins an impeller, right? Or that spins a turbine that turns the fuel pumps, and that puts it in the engine. That is about as simple as you can make an engine with a turbo pump. Now, like the only things that are simpler are like solid rocket boosters, pressure-fed hypergolic systems, or just straight pressure-fed systems. It doesn't get simpler than that. But the Merlin ones have a kind of ace in the hole, and this is part of the reason why Falcon 9 is so damn important. It's like such a quintessential thing, like how it was able to kind of revolutionize the launch market. I mean, you go back here and you see the first stage come down and land, right? You need to be able to make a throttleable rocket engine to do something like that. Now, don't get me wrong. There are other rocket engines that can throttle. RD-180s can do it. Space Shuttle main engines can throttle. RL-10s can throttle. A lot. Like a lot. The Merlin engine can do what's called deep throttling. Not all rocket engines can move from like 99% throttle all the way down to like 10% throttle. If you go too far low with your throttle, you'll just flood the rocket engine, and it won't work. You won't be able to sustain combustion.
Go at throttle up.
You won't be able to sustain combustion chamber pressure. Basically, you'll flood the engine, like a compressor stall on a jet engine, something similar to that, right? You're delivering too much fuel, the RPM is too low. The Merlin engines can deep throttle. They have a throttleable range from 100 to about 40. So 60% of the rocket's thrust can be taken away. That is quintessential for Falcon 9 being able to land. That's really, really important. So even though the Merlin has simple turbine machinery, the reason why it can throttle is because of its injector. The fuel injector on the Merlin engine is actually a radial firing injector. In rocket science, it's called a pintle injector. Basically, with a rocket engine, you have the combustion chamber here. Fuel usually gets delivered axially like this. So like if you have like a Saturn V first stage, they have an axial fuel injector. The fuel goes this way and it goes out the rocket engine that way. So with these Merlin engines, you have a radial injector. So the rocket engine is pointed this way. When the fuel comes in, it actually gets sprayed up and down. If the bottom of the rocket engine's that way, top is that way, it goes left and right. And it's kind of like like people that have those pop-up sprinklers. The sprinkler pops up and then it kind of shoots the water out in a cone. Literally that. That's a pintle injector. Or well, it's just a pintle, right? Because they have that radial injector, that makes the engine extremely throttleable. Because they can sustain combustion at different turbo pump RPM, which is because you're shooting outwards and filling the entire combustion chamber with explosion. It's a really important thing to understand. So Merlin engines, as simple as they are, do have an ace in the hole from their fuel injection system. That's what allows Falcon 9 to land. Without the pintle injector, Falcon 9 crashes into the ground when they try to land it because they can't throttle the engine down enough. They'll try to throttle the engine down, they'll lose it, and boom, right into the ground, which is basically what happened a couple of times when they were trying to land Falcon back in the day. Nice. Do they keep the oxidizer constant fed? Yep. Minuteman, what was your question? Ta. Yeah, it's 1/6 the size. I'm not sure what you guys are talking about. I didn't scroll far enough. So I guess there's like an adjustable throttle plug that causes that, like a sprinkler, but it moves in and out. Something like that cell. We don't know exactly what they have. They're not going to show it. Rocket fuel delivery systems for rockets are one of those things that you just kind of don't talk about. Helium-3 mining. Oh, word. Seems simple enough. So, the principles of operation of a rocket and what a rocket does is actually not too hard to understand. You know, there's a saying, it's not rocket science. Honestly, rocket science is pretty simple. Look at me, I'm a moron. I figured it out. The thing about rocket science is that it's hard to do. It's hard to do it. It's hard to make a rocket. Anybody can understand how a rocket engine works. It's really not that complicated. You literally take liquid fuel and oxidizer, you deliver it in so it atomizes it, and you light it on fire, and it gets pinched in a throat and shoots out the back at a really high speed. It's not complicated. Like, blow up a balloon and then let it go. That is what a rocket engine does. Not complicated to understand. Doing that and making that actually do the things that we're talking about, that's difficult. That's the hard part. What about rocket appliances? I mean, Boxy, you got a rocket-powered toaster, and you're not telling us? You need to tell us. You need to tell us how your rocket-powered toaster works. I mean, if I had to choose, I'd probably want like a rocket-powered washing machine or something. Or rocket-powered dryer. Yeah, you'll dry your clothes really fast. I mean, don't worry about it here. This is the place to learn, dude. You're seeing some outgassing there from the nitrogen control systems. It just sounds like an incinerator with extra steps. Shut up. Rocket-powered phone charger. Rockets do generate a lot of heat, and that heat could be harvested as energy. You could use a rocket to charge your phone. Sure, it would charge your phone really fast, and hopefully the wire that goes to your phone can take it, and hopefully your phone's battery can take that, because yeah. Oh, in that case, I had a rocket-powered washing machine. You toss a grenade in on deployment. Yeah. Your toaster runs on fairy dust and unicorn farts. Yes. So is the Merlin 1D open cycle, where the Merlin back is closed cycle? It's not closed and open cycle short line. It's called regeneratively cooled. That's regenerative cooling. The Merlin 1D is more open cycle. But yeah, that's you don't call it. I mean, yeah, I guess you could call it that. Yeah, it's closed cycle, but it's closed cycle regenerative cooling, as opposed to like a closed stage combustion cycle. There's a bunch of different ways to make the rocket engine do, you know. Cubat, you're not the only one to say that, to be honest with you. I mean, honestly, that just sounds like it'd be, you know, fun for someone for like a second, and then like tragic after that. Like, to be honest with you, like just being real with you, man. Rocket powered toilet flusher. I mean, jiggling the handle buster doesn't sound like a good idea if you have a rocket powered toilet. Yeah, Forge. That's what I thought. It's MMOD all day. Oh yeah, there's that article from the thing from Tim. Sorry, I had to bring it that low. Dude, it happens literally on a daily basis. You can't talk about rockets without some random coming in here and be like, that looks like a pee-pee. I'm like, yeah. Yep. You're not wrong, man. Like, what do I do with that? Do I be like, oh my god, how dare you? No, I'm not that kind of guy. Like, what do you do? Just like, all right, you know. It happens literally on the daily, dude. On the daily. It's okay. It's Twitch, man. We're streaming on Twitch. I can't expect everybody to be like, yes. The rocket engine is phallic shaped for maximum aerodynamic efficiency. Like, I can't expect that out of Twitch chat. You'll go nuts if I would go insane if I expected that from people, dude. You gotta be kidding me. Just put the Austin Powers video. Wow, it looks like a giant dick. Take a look out of starboard. Oh my god, it looks like a huge pecker! Oh, wait, that's not a woodpecker. It looks like someone's privates! We have reports of an unidentified flying object. It is a long, smooth shaft, complete with 2 balls! What's that? That looks just like my husband's one-eyed monster! So, sometimes you gotta double down on the crazy and embrace the chaos. Because it's fun. Hey, what's that? It looks just like a big Woody! Woody Harrelson? Can I have your autograph? Oh my lord, look at that thing. It's so big. Nah, that's just a little prick. It's a flu shot. You've been in the coldness of space. Well, it looks like a giant Johnson. Yes, sir. Get on the Horde of British Intelligence and let them know about this. Yes, sir. It's still funny. It's still funny. That's still funny. It's hilarious. No, Lemprod. We're talking about Dr. Evil's rocket. Matt, it's happened before. They've had 2 launches within 24 hours in the past. Yeah, but it is rare, but it does happen. They were trying to go for 3 today, and they said, nah, never mind. There's a 1970 F-250 restored on car and driver. Price is a little absurd, though. Oh. Oh. No. Oh, I want it. I want it. I want it. I want it. I can't afford it. Yo, it's got jump seats, dude. Oh, that's sick. Wow, look at that frame. Holy crap. How much? It's $285,000. 325 G's for the Heritage package. Okay. So our fire pit is a washing machine drum that we also throw solid propellant in. I've never seen such metal go from cold to glowing white in 10 seconds. It was really cool. Physics is fun, man. You hear the rain. Shortline, I have the ceiling, the whole drop ceiling installed. And you still, dude, you know how hard it has to rain for you to hear it in here? It is pouring, and it's been pouring for like 8 hours. Why'd they ruin it with the lift kit? That's a tastefully done lift kit. I don't have a problem with that. And it's an F-250. It's supposed to be up like that. It's very nice. It's very well done. Yeah. Like, you could buy a house for the price of that truck. I don't need to do that. I'll literally, for 285 G's, I'll just figure out how to do that myself. A bit loud, but pretty cool. Seen it. Yeah. Yeah. It's been linked already, Forge. Like 6 or 7 times. Oh, boy. Prepare to fast forward. Preparing to fast forward. Fast forwarding, sir. Fast forwarding. It's all rain, Ford. It's close to the ocean, dude. It's not even snow. Snow's up north, dude. Make it 7. All right. Forge, how many times do you think the F-35B thing has been linked? I get that's been sent like 3 or 4 times this stream, dude. But also, it's like it's super difficult to watch. Oh. Yeah, so I don't got anything. It's all rain down on the Cape. It's all rain. Always has been. What are we looking at? Alcohol. We're looking at a Falcon 9 second stage with the O3B mPower 1 and 2 satellites attached. Coming up on deploy here in a moment. Actually, there's another burn here. There's SES-3 and SECO-3, and then Satellite 1 and Sat-2 deploy. Should be happening in about, I don't know, 15 minutes, something like that. Actually, probably less than that. They are chilling down the M1D. You see those vent lines up there? They're putting liquid oxygen and RP1 back into the engine. They're priming it and thermally conditioning it for firing here. You're in the last mile north of the U.S. We've gotten very little snow. Yeah. They just flow RP1 in liquid oxygen and don't burn it to chill it. They trickle it in. It's just like priming a lawnmower, Pete. Yeah, you push a little primer. Yeah. They use the pressure in the tanks. They open up some valves. Now, the valves to the fuel injector, to the injection plate, they aren't open. They open a valve to the vent lines instead. So, yeah, it's the turbine machinery, dude, not the actual like whole rocket engine. The turbine machinery, the pumps, they need to be taken down to operating temperature. So that's what you're seeing them do there is just start flowing liquid oxygen a little bit from the tanks. If I had to guess, this is a huge guess, I don't know how SpaceX operates, but they're probably using some of the ullage tank pressure to do that. So the tank is pressurized, right? And it's designed to maintain a constant pressure. So if they open the lines that go to the engine, right? And they use some of that tank pressure to fill up the turbo pump with liquid oxygen and RP1. And inside of the tanks, inside of the fuel tanks, there are smaller tanks that are helium composite overwrap pressure vessels. Basically a propane tank that's wrapped in carbon fiber. And when the pressure starts to go down, those helium tanks automatically let off some gas into the RP1 and LOX tank to keep it at a singular pressure. Exactly. You don't want to flash freeze your turbine. You flash freeze the, well, it's the impeller. It's the impeller that they have to worry about. If you flash freeze the impeller, it's simple. This kills the rocket engine. Yeah, that does a hard start. That can create a hard start scenario and a failure mode, which is bad for the rocket engine. Yeah. Yep. I think they're using residual tank pressure, Pete, but that's just because I don't really know what else they would use. How else would they get the fuel in there? The only other way I could do it is them heating up the inside of the tank, but to get the propellants to expand. But I don't think I need to say why you wouldn't want to heat the tank like that with fuel in it. Probably not a good idea. They're probably just using residual tank pressure, if I had to guess. Yeah, once again, huge guess. Don't know. That's autogenous pressurization? Yes and no. So autogenous pressurization does the job of those helium tanks. So if we're going to take, like, let's take the shuttle external tank, for instance. You still, a rocket on the way up has to maintain the same exact tank pressure the entire time, so the propellants feed correctly. So what they do is, as the liquid drains out, they replace it with gas. They're chilling it again. They replace it with gas. Those gases are called ullage gases. Now, where those gases come from depends. So if it's autogenous pressurization, on the space shuttle main engines, there's a hydrogen tap-off that takes gaseous hydrogen and puts it back into the hydrogen tank. And there's a gaseous oxygen tap-off that takes the gaseous oxygen, puts it back into the oxidizer tank. So their ullage gases are gaseous hydrogen and gaseous oxygen. And that's what keeps the tanks pressurized. Falcon 9 can't really do that because you can't really do that with RP1. You could do it with LOX, but remember, Falcon 9 is supposed to be simple. So the solution in this is a kind of more run-of-the-mill thing. They have helium tanks inside. The helium tanks make it non-autogenous pressurization. Their ullage propellants is coming. Their ullage gases are coming from the helium tanks. On the shuttle, it comes from the engines. That's I can't say the word. Autogenous pressurization. There you go. That's what that is. Starship does that too with the Raptor engines, for what it's worth. Why not nitrogen instead of helium for ullage? It's a good question, Pete. Good question. Why? Why do you think? Let's noodle on it for a second. Why would you use helium over nitrogen? Doesn't helium leak a lot and is expensive? It is. Jim's got it. It's the mass, dude. Helium has lower mass. Simple as that. Another good thing about helium is that helium really doesn't solidify. It really doesn't. It doesn't solidify, and it really doesn't like to liquefy either, like hydrogen. It does leak, but it's not really, it does leak kind of like hydrogen, but you put it in a composite overwrap pressure vessel and it won't leak as much. But you got to remember, they're not storing the helium as a liquid. They're storing it as a gas. So the pressures are different than storing like liquid hydrogen. So helium, it will leak if you try to get it to liquid form and it starts boiling, right? But when you just store it as a gas, as a certain temperature inside of the tank, yeah, it stays gas. Yeah, Corey, it's going up big. So, Pete, they use nitrogen for their attitude control systems. So, like Falcon 9's first stage has a nitrogen system for the RCS. SpaceX calls it an ACS. Helium is inert. Nitrogen is an explosive.
Acquisition of signal. Hula.
They have a reacquisition of signal. Dead meat. Nitrogen is inert as well. I'm pretty dang sure. Yeah. Helium is a noble gas, right? Yeah, that's what it is. Will the continuing depletion of the world's supply of helium result in Falcon becoming too expensive eventually? Most explosives are nitrogen-based. I can get into the chemistry in a moment. GUI, like in 100 years, long after Falcon 9 has stopped flying, but yeah. So, Dragon, you correct me if I'm wrong here. My chemistry is not nearly as good as yours. I will defer to your judgment.
Go at throttle up.
So, dead meat. So, like, take nitroglycerin, for instance. They use that nitrogen so they can store the explosive in a stable form. Think about, like, just because you have nitrogen in there doesn't mean it's non-reactive. So think about nitrous oxide for a car. N2O. It's 2 nitrogens and 1 oxygen. Basically, that nitrogen is just carrying the oxygen around with it till it comes the time that it needs to be used. In this case, like nitrous, for like a nitrous injection system on a car, when they spray the nitrous into the car engine, you're upping your oxidizer content. Your oxidizer ratio goes up, because if a car is just naturally aspirated, it's just pulling in ambient air. Think about it like this. Our atmosphere is like 80% nitrogen, 20% oxygen. So you have 20% oxygen if the car is just pulling in air. With nitrous, you're replacing that 80 to 20 mixture with 60-30. That's why nitrous gives you big boom, because you're moving more oxygen into the engine. If you move more oxygen into the engine, right, you can deliver more fuel, make a bigger explosion. This is why nitrous is like one of the cheapest power adders, because it's very simple. But nitrous by itself doesn't really do anything. It has to combine with something that it can chemically deflagrate with. It has to combine with something that's combustible. The nitrogen is there to just keep it stable. Oh, nice, Cyborg. That's cool. So helium is used for the hydrogen tank pressurization, or does it really depend on the engineering team? It depends on the rocket. On SLS and the shuttle, they don't use helium for the tank. The shuttle engines use autogenous pressurization. Yeah, this is getting into chemistry, guys. So, like, what they do, like, certain rocket propellants have certain elements attached to them to keep them stable. So, like, take methane, for instance. Methane is CH4. So hydrogen is really good. That's a really efficient rocket propellant. It's the best you can get. But hydrogen's a pain in the butt to handle, right? Methane is okay. It's not as good as hydrogen, but it's close, because CH4 is methane. You have 4 hydrogen in there, and then you have 1 carbon. Now the carbon is going to give you a really energetic explosion, right? When you combine it with oxidizer and then it meets a source of ignition, right? The carbon is going to give you a really big explosion, but those hydrogen give you a really efficient explosion. So you get kind of the best of Carolox and the best of Hydrolox with methane, right? But methane is also a lot more easy to handle, because that carbon atom. Because methane is easier to store as a liquid because of that carbon. That carbon is kind of holding all those hydrogens together, and it prevents the hydrogen from going off and leaking out like what it does with just straight LH2. Yeah, there you go, Parasp. Yeah. Good questions, guys. What is the chemical composition of hydrazine? Monomethylhydrazine. So it's MMH. Or actually, hold on. MMH is just the acronym for it. I actually have to Google this one. Hydrazine is maybe later. No, close. Get out of, get off the screen. N2H4. Oh. Whoa. Yeah, no wonder that stuff's bad for you. Ooh. Yeah, that's that. Yeah, you don't want to. Yeah, you don't want to do that. In chemistry, the methyl group is CH3. As methane is CH4. Interesting. What does the X stand for with the H4? No, that's how many of it is attached. So, Mab, if you have like CH4, for instance, it'd be CXH4. No, that's not right. That's not right at all. CH4 is just carbon with 4 hydrogen attached to it. How can I explain this? Think about part hierarchy in KSP, Mab. XH4 is putting it in 4x symmetry. Does that make sense? So you have 4 here, 4 here, 4 here, and 4 here around whatever it's attached to. I'm pretty sure that's what that means, but chat, correct me if I'm wrong. Chemistry is not my strong suit. I try, Minuteman. We try to learn here. Yeah. Big nerd, a bunch of nerds in here, myself included. What context is the X? So, let's load up that hydrazine again. So, hydrazine hydrate, N2H4XH2O, means you have, that's that right there. See what I'm looking at? This stuff over here. But that's not exactly XH2O, I don't think. Yeah, see, long story short, Map, you can have a hierarchy of a bunch of elements together like this. CH3NH2. Oh boy. See what I mean? It's like a hierarchy in Kerbal. That's that chemical. That's it. It's been a while. Chemical compound, right? This is a compound. What's your background? Are you self-taught? Koopsie, I'm self-taught. Yeah. I just been doing exactly what you see here for like 10 years. You learn a lot. I learn a lot. There's a bunch of really freaking smart people in here. I would say that I'm the dumbest one here by a long shot. UDMH is linked on that page too. It's very impressive. Fair play. Right on, man. Thank you. Yeah. I just like learning this stuff, dude. It's cool. I think it's... Pete's like, I'm the dumbest. I highly doubt that, man. Oh, look at that shot. Dude, look at Oz. Yo! Did you see that? Mab, you see that? Yo, there it is. That's looking at Australia upside down. There's a joke somewhere in there, dude. I don't know what it is. I mean, I'm doing a master's in space science and engineering, which you probably know more about it than you. Yeah, Coop, I just seep in the knowledge from the interwebs, man. That and, like I said, dude, that's cool, though, by the way. That's awesome, man. It's a sweet degree. I keep this on my desk for a good reason, man. I love this stuff, dude. I love it. It's my favorite. I read this book for fun because I'm a loser. Not really, but yeah. Like, that's what I enjoy doing. I think it's super freaking interesting, man. You come from the land up downer? Sea last. Oh yes, dragon. Absolutely. When it says XH2O, it's indicating that it's not anhydrous, so it has some water coordinated to it, and the X indicates it can be more than one number of water molecules. So, Dragon, that would work like if you had a subassembly of like 3 components and you put it in radial symmetry and Kerbal onto something, right? Like, right? It's chemical compounds have a hierarchy like Kerbal, don't they? Huh. What's the purpose for magnesium iron silicate hydroxide? Sounds like an explosive. Gagen's last. Okay. For nitrogen compounds, check it out. Oh, dude, that's so cool. You might want to Google that. This is one of those stupid chemistry. Nice. I expected better from you, man. We lost him to Chem 101. Could nitrous be used as a rocket fuel? It could be used as an oxidizer. Nova, because you got to remember, nitrogen is inert. It's non-reactive. You can't really do much with it. Now, just because it's non-reactive doesn't mean you can't heat nitrogen up to get it to expand, right? You could do that. That'll work, but it won't react with anything. It won't detonate. It won't deflagrate. Right? Did I say that right? I think I said that right. So what does that leave? Oxygen. So nitrous can be used as an oxidizer. In fact, so you want to hear a cool one? There are solid rocket boosters, an SRB, right? That is what's called a hybrid engine. So they use liquid oxidizer in the form of nitrous, and they spray nitrous into an SRB to get more performance out of the solid rocket motor. Virgin Galactic with the plane that detaches and then shoots up into space, that's a hybrid SRB with nitrous injection, which is actually really cool. Does the same thing that it does in a car, it makes a bigger boom. Definitely great. What did you Tessa? You do that on your own time in the loo, okay? Okay, we're coming up here to SES3. Nice, Forge. Awesome. You can use nitrogen in a cold gas thruster. That's right. Yes, coordination chemistry has multiple groups coordinated to a central molecule atom, and it can exist in many different configurations. E.g., some common geometries are octahedral, tetrahedral, and triagonal bipyramidal. That's freaking wild, dude. Oh, Dragon. Now it's a rabbit hole, isn't it? It is. Damn it. I guess no comment on the tanker design difference mentioned earlier. Are you talking about me, Journey? I'm sorry, I'm on a crazy journey into chemistry. What do you need, man? On the Starship tanker, maybe that the tanker will keep low altitude like the booster and could be used for propulsive landing and need solar panels. No flaps could mean landing legs. I mean, maybe, dude. Yeah. For reference, methane is tetrahedral. Yeah. Wait. The angle? Wait, Dragon. The angle matters? Wait a minute. That matters, doesn't it? It definitely does. I know enough about science. If they're labeling it, that means it absolutely matters. The angle that they're attached matters? Holy crap, bond angles are so important. Oh my god. Oh my, dude, this is a huge rabbit hole. Oh no. Oh no. What did you guys just do? Oh no. Don't go down this road. It's nothing but heartache. Oh, I want to though. I'm gonna jump. I'm gonna do it. I'm gonna do it. I'm gonna be reading chemistry. I'm not gonna get any sleep. Damn it. Nova, why would you do this? No, that's so cool, man. That's awesome. I want to learn everything about that. That's so legit, dude. If the angle is wrong, it can mean reactions don't happen. What the frick? I'm gonna go buy a chem book. Dragon. All right. You piqued my interest. Give me what chemistry book should I buy? I need to buy one. I need to learn it. That's so freaking cool, dude. Each bonded pair of electrons wants to be as far away from any other bonded pair. Page 3 and 4 for HLS tankers. All right. We will check that out after this mission. Ford, seriously, remind me. I want to look at that. Last, okay? Look up Nile Red. He makes grape soda out of a nitrile glove. What? Ignition is about the history of rocket fuels. Okay. Wait until he hits chirality. Every person that I've talked to that's ever taken a chemistry course hates it. Especially organic chemistry for whatever reason. And so I've kind of like shied away because everyone's like, no, frick that class. And I'm like, okay, I'll take your word for it. Orgo, it shows up first, and that's why they hate it. Ignition is a good crossover between rockets and chemistry. Okay. What does the O3B mPower under the time mean? That's the name of the satellites, Geek. mPower 1 and 2. It's Eutelsat's a Eutelsat communications satellite. My chem professors back in the day specifically told me not to take organic chemistry unless I wanted to be a chem major. That's so legit, dude. He's made grape soda hot sauce out of plastic gloves. Yep, they're really venting her now. They must be doing that to try to keep the engine cool, guys, because I've seen them vent and thermally condition the engine like 3 or 4 times on this coast. Yeah, I got the link, Flecken. Thank you. Let me just make sure that was the right link. Everybody's linking a lot of stuff. Yeah, okay, that was the only one. Cool. For Organic Chem, the textbook by Clayton is one of the best. Got it. Too bad they don't even have a good camera angle towards Earth. Well, they had to line it up for the burn, BD. Look, I mean, this thing is kind of close to apogee from what I can tell here. Molecular polarity. Yes.
Go at throttle up.
Chirality. Molecules can be right or left-handed. If I recall correctly, all sugar you find is right-handed. You can create left-handed sugar, but nothing alive can eat it because the angles are wrong. So mirror symmetry. Mirror symmetry. Why does that work? Why does that work?
Welcome back to our
Why does that work?
Mission.
That's not okay, dude.
We had an
That's weird, man.
At 5:48 p.m. Eastern Time from Space Launch Complex 40, followed by successful ascent, stage separation, a first stage landing, and 2 second stage engine burns. If you've been following along,
ambidextrous
we
sugar.
did hear during the previous coast period confirmation of a good orbital insertion after SES-2 on the nets. Yep. We're now coming up on the 3rd and final second stage burn for today's mission. That will happen at about T+1 hour, 49 minutes, and 52 seconds. This burn will be a relatively quick burn, another 30 seconds. And you'll hear that call out as SES-1 or SES-3, second engine start number 3.
Molecular bonds are struts. Dude, don't tell me that. I mean, it works. But all right, here we go. Here we go. Here we go. She's gonna heat up for a second, and
there you can see the Merlin
Wait for
vacuum
it.
engine is ignited for its third time.
Oh, she's getting a little toasty.
Again, a short burn, just under 30 seconds.
That's a really long burn, Shiva. Auto strut to grandparent or root part. Depends on the application. That's so strange.
You can see here that we're increasing the speed. Our current altitude is staying the same because we're at the highest point of our orbit.
They're circularizing.
So we're raising the perigee a little bit. And with that, we just had confirmation of second engine cutoff, number 3.
I think they're still slightly eccentric core. If I'm
Nominal orbit insertion.
NOI on burn number 3.
And with that call out from the ground teams, we are in the expected orbit.
I think they do that
As
so
a
they can
reminder,
deorbit
the
stage.
O3B mPower satellites are still attached to Falcon 9's second stage. They're on the very top of the rocket. We've got the first
could be
of
resonant. It
2
could be-
payload
could be
deployment
right.
events happening in just about 3 minutes.
Should we expect a custom clear coat for the trucks?
Now, these 2 mPower
No.
satellites, the O3B mPower satellites, are for our customer SES.
That's so cool.
The O3B mPower communication system comprises an initial constellation of 11 high throughput and low latency satellites, as well as SES's
Interesting for it,
extensive ground infrastructure. And these satellites were collaboratively designed by SES and the Boeing company. These satellites are the second generation of
There's a couple
the Medium
using
Earth
them. I don't know
Orbit,
if they're
or
here,
MEO
though.
system, that has been delivering high-performance communications to a multitude of services since 2014, to a variety of different customers operating in 50 countries today.
In your project, I made
These connectivity services range from 50 megabits per second to multiple gigabits per second and support mobile network operators, cruise ships, energy companies, as well as governments and institutions around the globe.
That's ridiculous, Trevor. How the hell did you do that?
Now, I mentioned Medium Earth Orbit earlier.
Mind-blowing stuff.
There's a number of different sort of large payload, orbit groups that satellites go to. These satellites are headed about 8,000 kilometers away from the Earth's surface. You can see right now our altitude is about 7,000 kilometers. So once we deploy these satellites, they'll have a little bit of work
Like
to
an
do
elephant movie.
to reach their final targeted orbit.
See it over there?
And so
Either that or it could
this
be a
is the
star.
first of 5 of these O3B mPower launches. It'll take them a few months to get to their target orbit, and then they'll jump into service near the third quarter of 2023.
It's flashing. So are you, and that's against terms of service. All right, get out of here. I mean, hi.
The satellites were built by Boeing, and the O3B mPower system comprises more than 30 technology partners, ranging across their ground system partners to their software development to the various hardware on the vehicle. So, first of 2 payload deployment events happening about 15 seconds from now. Got a view here on the top of the second stage looking up at the satellites.
Super serious. Why do stars at night flash? They twinkle. Fucking. It's just the light. The light is getting diffused by our
First
atmosphere.
mPower spacecraft. Separation confirmed.
The light's getting diffused by the gases in the atmosphere.
It looks like we have a confirmation
All right.
via telemetry of the first spacecraft separation. Maybe we'll get a shot of it here in view.
That wasn't the rain on my roof, Jim. That
You recall
loud
from
dumpster
earlier in the
slam.
webcast, both these satellites are stacked on top of each other. But successful deploy via telemetry. So with that, we have one more major milestone. That is deployment of this second and final spacecraft of the SES O3B
Yeah,
mPower
you can see
mission
some
for
stars
today.
up there. See them?
That deployment scheduled to happen about 6 minutes from now. So we're going to leave you with some space views, and we'll be back shortly for final payload deploy.
There we go. We had a good confirmation to deploy on Sat 1. Was this the Dash 15 launch? Huh? So, Flykin, the same thing happens during a hot day. You ever you've been in a parking lot on a hot day and looked out and you see it looks like the air is squiggling around? Same thing. Gas diffuses light. It makes it look like it's squiggly. They're stars, Tom Cream. Yeah, they were stars. The exposure is all screwed up. But yeah, those are stars. They were just brighter stars. The mirages? Yeah. I think we saw the moon back there, but I could be wrong. It could just be more stars. Now, like I said, stars twinkle from here on the surface. The reason why these ones are doing that is because the exposure on the camera is all screwed up. Cameras go a little haywire up there. The camera focus and the exposure rates get really screwed up there. This is why everybody's like, "Oh my God, that's a UFO! It's blinking!" No. The thing is that there's one star that's a lot closer than all the other stars, and the camera is deciding what exposure it should do. Right? So you ever like watched a video that's in a dark space, and then like a door opens and there's a lot of light coming through, it overexposes and then it underexposes and then it gets it right? Literally that. But in space. That's why they look like they're twinkling up here. The exposure is going haywire because there's a lot of light. Is there not a lot of light? The camera exposure rates can get confused like that. That does happen. It happens all the time. Heck, though some of these twinkles here that you see could just be it could be radiation. Oh, there's a little chunk of solid oxygen right there. It could be radiation. They fry the camera lens. DSLRs get roasted up there, and it kills pixels left and right. The history of hydrazine and its methyl derivatives are interesting too. Hydrazine N2H4 is a solid below 2C and has low potential energy, 622 kilojoules per mole. Monomethyl hydrazine CH3NH2 is a hydrazine with a single methyl group. This lowers its freezing point to minus 52C and gives it higher potential energy, 1304 kilojoules per mole. That's crazy, dude. Unsymmetrical dimethyl... Oh, UDMH, right? That was UDMH. Unsymmetrical dimethyl hydrazine adds another methyl group, H2NN-CH32, which again adds more potential energy, 1975 kilojoules a mole. For space use, MMH and UDMH have the benefit that they don't become solid. Cool. How cold is it where the rocket is? It's not cold and it's not hot. Laser Juice. Hey, Tom. Right on, dude. Thanks for the sub. 7 months. Appreciate it, man. It's not cold. It's not hot. Lasers. There's nothing up there. It's vacuum. There's nothing. That's an important thing to understand. That doesn't mean that heat and the absence of heat, what you would call cold, doesn't happen in space. This blackness right here, there's nothing. There's nothing there. It's not air. There's nothing. So that's the sun rays just keep traveling until they find something that absorbs the heat, like the spacecraft. So, like the vacuum of space is nothing, but the surface of that nozzle is extremely hot right now because it's sitting in the sun. But here's the thing. There's no way to shed the heat. What are you going to do? Sweat? Can't do that. What are you going to do? Have a fan blow on you? That doesn't work either. There's no air to push at you. There's nothing up there. So the rocket engine is actually super freaking hot right here and super freaking cold right there in the shadow. It's really strange stuff. It's hard to kind of understand, but the big thing that you got to understand is that space isn't cold, space isn't hot. It's nothing, because there's nothing there. There's no matter. There's just nothing. It's absolute zero. There's nothing there. Now, don't get me wrong. That doesn't mean that there aren't things in space. Like, the way I like to describe it is there's particles floating around up there. There's all kinds of stuff floating around up there. It's just not enough to create any usable pressure or anything. Like, there's still air up there where this rocket is right now, even almost 7,000 kilometers that way. So about 4,500 miles. Up there, there's still air. It's not enough to breathe. Not enough to breathe. But there's air up there. And that does perturb the vehicle. The vehicle actually creates drag up there. It'll eventually come back down. But there is air, but you got to understand that the air that is up there can get heated up. It can cool, but it's not enough to be able to cool something. There's literally not enough matter there to cool anything. In space, it's nothing. It's not hot, it's not cold, it's nothing.
Our mission today for our customer, SES.
Stand by
now,
for
about
the
6
second
minutes
deploy.
ago, we deployed the first O3B mPower satellite and are awaiting deployment of the second and final payload. As a reminder, the O3B mPower system is capable of delivering connectivity services ranging from 50 megabits per second to multiple gigabits per second to multiple mobile network operators, cruise ships, energy companies, and governments and institutions around the world. The O3B system has been delivering high-performance communications to customers since 2014 across 50 different countries.
That's right, Dead Meat.
Now, we're coming up on payload deploy. We're looking right now at a live view of the second stage.
They do fly.
Up at the second mPower spacecraft. And coming up shortly on payload deploy.
It should be in the document, Geek. You have to ask Max when qualifying starts. I'm gonna come in right at qualifying.
Second mPower spacecraft, separation confirmed.
We saw the decoupler go. Second mPower spacecraft is deployed per mission control. Very nice.
There was confirmation via telemetry of the second spacecraft separation. And it looks like what we have on screen is actually the payload adapter fitting, so we may not get a view of the spacecraft separating. So with that, we're going to end our coverage of the O3B mPower mission.
It depends on where it's going, Reagan. That's really the big one.
To our customer, SES, for entrusting us with today's
These
mission.
satellites are going to different orbits, remember? So the deploy time changes.
Administration for supporting us. This launch concludes our 196th overall mission to date and our 58th launch this year. Thank you, all our viewers, for tuning in and for your continued support. We hope you have a wonderful weekend, and we'll see you for the next launch.
Thank you, Shiva. I'll see you tomorrow, buddy. Because SpaceX is launching again tomorrow. Think it has enough fuel left to deorbit. That is part of the mission profile, Deadbringer. Yeah, they're gonna bring that stage back down. They're gonna let it coast to apogee and then do a retro burn. Yep. That was anticlimactic. I wanted to see video of the second stage re-entry. Yeah. All right, guys. Well, that was the O3B mPower mission. Excellent. All right. Now it's time to do our own launch in KSP. Let's do it.